Hello everyone, my name is Caden Herring and I'm a consultant at Encryption Consulting. Encryption Consulting covers all the aspects of data protection such as encryption, data, security, key management, and privacy, and we help clients to understand and implement these models. In our last video, we introduced you to the concept of machine identity management and how it works, and in this video, we'll look into some of the factors that lead into the requirement of machine identity management, challenges faced, and the best practices that are followed across industries while implementing this concept. So, a little review about what machine identity is exactly. So, with the ever-increasing digital transformation in the current world, there's a vast increase in machines. So, the rapid migration to cloud technology pushed the firms to move beyond the scope of network perimeter and legacy firewalls. So, in this scenario, machine identity is coming to the picture. This machine identification is a digital credential or fingerprint used to establish trust and authenticate other machines. Regardless of the number of identities involved or the complexity of the enterprise network, it's essential that the whole machine identity lifecycle is effectively managed, and this ensures that access is only allowed to legitimate users or machines. So generally, the user's identity is represented in a username or password. When a user logs into an application, they enter the username and password, and it checks the username and password in the database, and if the credential matches, then the user is authenticated and can access the application. Similarly, machines need to be authenticated for secure communication with other machines. Machine identification is much more than a digital ID number or a simple identifier like a serial number or part number. It's a collection of authenticated credentials that confirm a system or user can access online services or a network. A machine cannot enter a username and password. Instead, they use a set of credentials that are better suited to highly automated and linked settings. Machines have digital certificates and keys used to establish their identity. And then to secure network communications, every internet protocol such as HTTPS, SSH, FTP, and so on, check and authenticate machine identities. Machine identities also help to achieve the zero trust security model, and basically what that is the idea of whether you're inside or outside an organization's network, everyone must be authenticated or even have their activity continuously monitored for complete access control. So, what are some factors that contribute to machine identity theft? So first we have CA compromise. Certificate authorities can be compromised when attackers steal their private key. So attackers can use these stolen private keys to sign certificates for malicious applications and fool browsers into believing they are trustworthy. These certificates, known as rogue certificates, are widely used by attackers to spread phishing and man-in-the-middle attacks. As a result, certificates of fraudulent servers and applications can be signed. And then certificate outages. Certificates issued have a validity period associated with them. So if a certificate is not renewed before it expires, it can result in a certificate-related outage on the system that it supports. Until a new certificate is installed, the unplanned outage and associated downtime will persist, and certificate-related outages are difficult to identify without knowing exactly where it's installed or who controls the system, so it's really important to control these. And then we have operational inefficiencies. Each digital certificate that serves as a machine identification takes some time per year for the organization to manage. With thousands and thousands of machine identities, the overhead can quickly increase, as you can imagine. And then there's unknown revoked certificates. So sometimes digital certificates get removed before their validity period expires because their private key gets compromised or the application to which the certificate is associated with is no longer operational. Happens all the time. So sometimes certificates may not be revoked by the certificate authority or be on the certification revocation list if it's not updated on time. And then this lets the revoked certificate seem valid. So, for example, if a certificate has not been revoked on time for an unused application, an attacker could use it's called an orphan certificate. You can use it for phishing attacks if an application has been taken down. So here are some challenges for machine identity management. This is why it's so important. For visibility, if there's a large number of certificates and keys in an organization, it's really difficult to track all of them. Many organizations even don't really know how many certificates they have, their validity period, and the policy that they comply with. So it helps to keep all of this information in checked and organized for auditing purposes. And then the next problem is a lack of ownership and control in some instances. So for some organizations, the certificates that are used by various teams and networks, but there's no consistent policy about how they're used, who can access them, the key rotation, the certificate renewal, the key storage, and so on. All this needs to be properly managed. And then there's protection. Digital certificates to the machine identities must be provided by a trusted certificate authority. Private keys must be stored in a hardware security module, or HSM for short, and therefore protected from compromise. Machine identities can't be trusted unless these safeguards are in place, because trust is everything with keys. And then there's automation. Manual management of certificate life cycles is not just time consuming, it's prone to errors, and it's also highly inefficient. Manually issuing, revoking, renewing, and auditing certificates can lead to a lot of downtime and outages. So, what are some best practices we can implement? We can centralize management. There should always be a centralized machine identity that helps streamline policy implementation among various devices. Certificates can also be group based on multiple parameters like expiration, criticality, etc., and implement group policy, making it easier to manage them. There should be proper policy management that prevents unauthorized access and allows machine identities to do their job securely. And then there's automation. We already talked about this, but machine identity management processes can be automated that help in defining an action for a single machine identity as well as for an entire group. All the actions can be defined in advance and can be triggered based on specific conditions, such as enrollment, provisioning, renewal, revocation, etc. And this can all be automated, which helps maintain machine identities to be up to date and effectively eliminating outages. So, in short, the entire machine identity lifecycle should be automated, including certificate and key lifecycle management that prevent errors and can be done in manual actions. And then there's storage. As best practice, all machine identities such as SSH keys, certificates, and keys of all types must be stored in a hardware security module, preferably that's FIPS 140-2 level 3 compliant. HSMs help keep the certificates and keys secured even when the user network gets compromised. And then there's key rotation. Organizations must rotate their SSH keys after a certain period that helps prevent the same keys from being used over a long time. Key rotation helps strengthen the SSH key security and protects against attacks like key sprawl. And the key rotation process should be automatic rather than manual so that it's a regular process. And then there's enforcing strong security policies. Organizations must be set up and enforce strong security policies to keep their machine identities secure and ensure that every machine identity complies with appropriate regulation. Implementing strong security policies also allows monitoring in every aspect of the machine identity, which can be really useful for auditing. And then there's machine identity auditing specifically. There should be auditing of machine identities at regular intervals, which helps in finding vulnerabilities like expiring certificates, weak passwords, etc., and it helps to prevent outages. Auditing can also be automated using third-party tools, and regular auditing helps an organization to improve its management strategy. So this brings us to the end of the video. We'll come up with some more interesting and useful cryptographic content soon in the next video. And if your organization's interested in learning more about machine identity management or anything related to cryptography and security, you can reach out to us at info@encryptionconsulting.com for more information.